Okay, hello. We're taking a look at problem 8.2 Microsoft Excel structured activity that I've called number 3 from the chapter. And pause the video and read the problem as well as the questions so that you can see the answers that are the correct ones for this problem. If you can get the correct answer for this problem, even though Cengage may have changed these values in your given problem, the process is the same. So we have a average annual premium of 1,463, and they want you to construct a confidence interval, and they give you the data in the spreadsheet, and they want you to create the formulas to calculate the values that you need to answer these problems. So here's that spreadsheet that was given from Cengage. You could just as easily use the statistical toolkit that I gave you to work with to calculate these same values. And in fact, when I used my toolkit, that's where I realized where I had made a mistake. Yes, even I make mistakes in calculating these. I want to talk about how you avoid making those mistakes. Obviously, for the first, we're going to use the count to count the number of values to get the sample size. We use the average built-in function to determine the point estimate of the mean, and the standard deviation, the sample standard deviation formula is what you want to use to calculate the standard deviation. And this is where I made my first mistake, although you can make this kind of mistake in the other two values as well. I'll double click this. When I typed in my formula, I had not highlighted all of the data. So I actually got a value for the standard deviation that was incorrect, which caused my margin of error calculation to be incorrect, and then also caused my confidence interval values to be incorrect. So always pay attention to and make sure that you've highlighted all the data values when you do your intermediate calculations. They give you the confidence coefficient. Obviously, 1 minus the confidence coefficient is the level of significance, and that's the value that's used in calculating the margin of error. Now, this is a pretty strange looking formula, but since they don't give you the ability to type in any intermediate formulas anywhere else on this worksheet, you kind of have to string it all together. So obviously, they ask you to round to 2 decimal places. I like to take the absolute value when I'm calculating the margin of error. That way I can just add and subtract that value from the mean. It's the standard deviation divided by the square root of the sample size, multiplied by, and in this case, because we don't know the population standard deviation, we have to use the t-distribution. And what we want is the inverse. In other words, we want the t-value for this level of significance divided by 2, and the degrees of freedom is simply the sample size minus 1. And we want that value to 2 decimal places. So look very carefully at this formula so that you can see what I've done here. And obviously you can type these two components in either sequence. They'll still come out to be the same value. So margin of error of 136.94 gives you the confidence interval. If you subtract that value from the mean to get the lower limit, and add that value to the mean to get the upper limit. They give you that national average again, so that your confidence interval does not include the national average. So that would lead you to believe that the average annual premium in Michigan is higher than the national average. Later on in Chapter 9, we'll see that we could use this technique to determine a hypothesis test, but we're not there yet. So that's how those values are calculated.